Working on electronic equipment has many hazards associated with it that can cause injury and or death. Please do not work on energized equipment unless you take proper precautions. Working on such equipment is done at your own risk and not at the prompting of information from this or any other YouTube channel. Hello and welcome back to Poor Man's Electronics Bench. In this part of the episode of work on unit number 1 of my two Sencore LC53 Z meters, I am going to go over some erroneous information and or discrepancies between the available schematic parts list and what was actually found installed in unit number 1 for the calibration adjustment trim pots, as well as other missing component information. My work will cover a brief overview of replacing all electrolytic capacitors and replacing the original and hard-to-access trim pots with top-access 25-turn components, as well as installing a main AC line fuse to ensure the unit's protection in case of a severe short inside of it. If this work and information is of interest to you, please pull up a chair and enjoy the content. As to be figured, I found myself going off into the land of inaccurate schematics and parts list once more. I decided to try to replace the trim pots on both of the boards. There's most of them are on the analog board, and there's only one on the digital. And I figured it wouldn't be too hard to do, so I was going over the parts list and looking at values and trying to make up an order, and then I thought, wait a second, maybe I better just take a minute and actually to check the values of what's really installed. I've just seems they have problems and then made orders with things, and then you find out that you don't have the right parts because what is really installed is not what's on the schematic, and lo and behold, that's what we have. If we go on reference to the schematic and parts list, the main group of offenders are the trim pots for the inductance calibration. There's 6 of them. Looking at the schematic, we've got a R1019. It's the 10 is designating that these parts are all on the board 1000 for the analog board, so that's the way they're all listed. So 1019 shows a 2.5K, 1021 2.5K, 1023 2.5K, 1025 2.5K, 1026. Well, that goes up to a 3K. Oh no, I'm sorry, I was looking at the wrong thing. I was looking up the series resistor. 1027 2.5K, 1029 2.5K. So you figure, oh, these are all 2.5Ks. And then if we go to the parts list as well, so R19, 21, 23, 25, 27, 29. They're listed as control 2.5K vertical PC mount pot. And there's another thing about this parts list that irks me is they don't have all the components listed on it. They stop listing resistors, or they skipped a bunch to the point where it's just aggravating. There's things, even it's kind of obvious if you look on the parts list, even for the display board. There's resistors on the display board. You can see them. They are there. And where's the parts list for the display board? Let's see. They do exist. There are resistors on it. There, I'm getting there. It's on the bottom. They put it in the bottom of below this guy here. Display board. Display PC board shows absolutely no resistors. I can't understand it. It shows absolutely no resistors on the display board for values, and yet if you go on let's just go on the, here's the display board, here's the the PC board layout. R4, R3, R46, R30. There is just a veritable crap load of resistors out here that they left off. So it's frustrating for anybody that has to work on things, and hopefully you'll run into, if you've got something that it's maybe drifted out of tolerance, that's fine. You can still read the value on it. If it hasn't been burnt beyond recognition where you can't find any value on it, then you're going by what might be the right value on a schematic, but then again, it might not be the right value on a schematic too. So it's very frustrating. And I'm just going to go into what I found here on the trimpots that I pulled. I took the time to measure each one, and they would be mounted on the board on this edge here. I started replacing some with some ordered trimpots. But the values of the trimpots, the R19 and R21, are 3Ks. The R23 and R25 are correct according to everything. Those are 2.5s. And the R27 and the R29 are 2Ks. Now, they did that for a reason. I'm not sure what, I'm not sure why, but they did it for a reason, and I was able to get things adjusted to the point where they seem to be working, so I replaced those with like-for-like values, and I'm starting to go through and install them and mark them as well. I was going to go through the process. I'm going to use, I got to do R27 and R29, which are the 2K, so you get to see some of the work as it goes on here. It's kind of slow because I am choosing to put some stencil markings on these to make them a little easier to read going forward. I do have the parts available. I got to shut off my screen capture recording here so it doesn't burn up data. See, I have a bag somewhere that has my 3Ks in here. Here we go, 2Ks, I'm sorry. We're getting down to the 2K values for what's left. 27 and 29 are 2Ks. And these are Bourne's trim pots, the model 3296Ys. The Y designation staggers the pins in a there's two common types. There's a W and a Y. The Y staggers the pins, puts the center conductor off of line of the other two. And what I'm finding is, of course, pins don't fall into line because they're not even close to the same size as the old one. So you do have to do a little modification to it. I'm just taking the center pin a few millimeters away from the body, and I'm keeping the part I'm holding parallel, but I'm pushing the whole thing out a little bit. I'm doing that to the other two as well. And it seems to drop right into place on an estimated guess there, so that's a good thing. And my next part I'm doing is trying to set the values of the trim pot to the same value as what was installed before. Like I said, I kind of went through and calibrated this thing, but things are awful jumpy and weird and wacky, and I decided to go to this route. These trim pots are about they're less than $3 a piece with tax and everything, and I ordered some spares as well. Keeping in mind that I want to keep the pin layout the same is this one. I wrote down the value I had on this one. This is the 2K, and it was 400 ohms between the pin on the left and the center pin. So I'm going to go pin on the left, center pin, and it seems like if you go pin on the left to center, when you're turning the screw in, your value goes up, and when you turn it out, it goes down. And these are 25 turn pots. So it's taking a few turns to get there. Jumped ranges. Close to 400 ohms, and let me double check what I had installed before. What was the original? The original was 399. Oops, I ended up bending the pin with the test lead. 398, that's close enough. I'm going to leave it at that. No sense fiddling with it too much. And being the person that's used to doing elaborate stenciling work on things, I ended up making a bunch of label maker P-Touch label maker stickers that has the resistance value, the resistor number, the resistance value, and then the range of the range that this is supposed to adjust. I'm going to go ahead and speed through this part a little bit so it doesn't bore you to death watching it. Okay, I'm going to go back to real speed, and I made a little boo-boo, not really a boo-boo per se, but I lost that little 2K that I cut on the label. I've got to either find it or make a new one of the two, but I'm just going to go into replacing one of these guys. This printed circuit board, it is double-sided foil, and it does have double-side connections. So you really want to make sure that you've got a good solder going through, and if you can tell there, I did my best to make sure that I had solder going through the foil on both sides. It requires just a little extra touch of patience when you're doing your soldering, because you have to give it a little more dwell time and a little more solder than just the single-sided foil. And make sure I get the piece positioned fairly well. Make a little effort to bend the legs out. To hold it in place a little better. And to make sure it's not too angular up on top as well. Get a little better lighting on this guy. And go into putting some solder on him. A little for the tip. And you're going to give yourself a little more solder than you would on just a one-sided foil. That, and you're also filling in a bigger void because you've gone to a lot smaller leads in here. Give it a touch more dwell time, and this printed circuit board seems to be fairly durable. I haven't done any damage to it yet, removing any components with a vacuum tool. I didn't use any foil. I got 3 pretty good joints there. And if you look on the other side, I've got, get back into focus. Got some solder coming up on the through holes, and that's really the way you want it to look. You might have angled it in a little bit, and it's kind of stuck at an angle, but it's still usable, still adjustable, and it's not hurting anything being like that. I could heat the center lead up and drift it over a little bit. I might do that. Just looks a little weird. All right, am I here? Okay. There, that straightened it up. No harm, no foul. Joint still looks good, and it's a little straighter in appearance. So I'm going to go and finish all my work to replace all the trim pots. I did replace the capacitors already. I chose some Worth 105 degrees. It's a German company, but they farm out, they make a large line of capacitors and inductors. They do farm their capacitor work out to China though, but are they going to stand the test of time? I would hope that they're going to do better than the Rubicons that were in here, because even though those were still functional, I didn't measure any that were really out of tolerance or had a high ESR to them. But considering that they've been in the equipment for so long, they had to be getting close to their useful life, and it was just time to make a change. Get something in here that might work for a little while more. I could have sprung for some Nichicons or Rubicons, yeah. But the Worth seem to be showing up in a lot of equipment lately, and I've seen other people online using them and having good results with them so far, but they haven't really stood the test of time for 20, 30 years in a piece of equipment. But if that's the case, this thing is probably still going to outlast me, so I'm going to continue on with the work, and we'll come back when I have something to reassemble and recalibrate. And I'm back with some progress, but before I put the guts back in, I was going to go over one minor change I wanted to make to things I was mentioning before. Is I wanted to put a fuse on this item. It has a thermal protector inside the transformer, but like I stated earlier, we know absolutely nothing about the condition of that thermal protection, how long it would take to trip, what temperature it trips at, will it trip? If it does trip, will it reclose after it cools back off? And in order to keep some of those issues from becoming a major issue and leaving me with a non-working device, I decided to add a fuse in the primary side of the wiring. And going over to the schematic view I have of things, I'm going to show you the line cord connection for the hot side. Is a gray wire that goes to switch 1, and which is the which is the ON-OFF switch, and sure enough there's a gray wire coming off of the line cord connection on the terminal strip underneath the protective cover, and that goes directly to and from the power switch right on top here. So I decided to interrupt that, and left me with a nice amount of slack where I can solder a couple wires to it, and pop riveted a fuse holder. This particular model of fuse holder seems to come in handy, and a 1/8 inch pop rivet works very well for mounting them. I also use a little brass backing washer, but I use a 1/8 by 1/4 inch pop rivet, and after as long as it's a thin enough piece of sheet metal on the chassis, that rivet is well below the plastic frame of the fuse, so it will in no way interfere or come in contact with anything. And then I chose a 375 milliamp fuse to install, as I noticed that this particular piece, this is 375 milliamp slow blow. I noticed that it was running, never saw it draw more than a 1/4 amp on any of the tests that I did with the unit. And then my only other thing is I put a little warning sticker on here, because also, going back to the schematic, there are some voltages involved in here that the transformer connections come onto a terminal strip in here and then go up to the switch. So you can see in the schematic all these leads, anything, you got 70 volt tap, 140 volt, 210 volt, 280, 350, and 420 volt AC tap. Those are all pretty hazardous voltages you really wouldn't want to run into by accident. And I'm also going to consider putting some sort of insulation over the rotary switch where it's going to be accessible. It's one of the two circuit boards covers up access to it for the most part on one side. The other one, I think the one that screws to the top, covers up access to it. This kind of leaves it open, but there's enough room in here where I can take one of those pieces of Nomex paper I have, fold it up into a channel, and put it over there just to prevent somebody. I can also put another warning sticker on there just to let somebody know that there can be some dangerous voltages on there. In fact, they're probably on there full time as long as the unit's plugged in. So along with that, I've got my boards populated with all my new capacitors, and I have them reassembled. Slid things back together, and I soldered my two little rivets on the connectors to keep them as keepers, to put them into place. And I did cheat a little with something that I have in hand that I'm familiar with that some people might not have. There's a couple different versions of things. It's considered it's not a dielectric grease. This is a grease that's used to prevent corrosion and it's not really a grease per se, it's a compound. It's an electrical joint compound. And this one has some copper infused into it. And what it's supposed to do is, on a really thin film placed between connectors, it will afford you a layer of corrosion protection. Now there's another brand of this stuff made by the company Sanchem. It's called No Oxide A. I'll get a picture of it up in a minute and show a link to it. And the no oxide stuff I used mostly in my telecommunications career for making connections on power buses, putting crimps on the ends of wires, and it's definitely a good product. I've never seen anything corrode or be damaged by it. It's a weird compound, because the last thing I saw, I did see a material safety data sheet on it, and it had the properties. It was non-toxic. I'm sure it has a flash point at a certain higher temperature or a combustibility point, but it's although it's not food grade, it's also not listed as being any type of toxin or poison, and it's probably edible. I suspect it's made of some sort of vegetable oil compound, but it does a very good job of keeping things from corroding. And I just put a small, you can see some of the, maybe a little bit of the golden color from the copper of some of those pins. I just wiped a tiny amount, just a film on those connectors to help me slide things back on, and it definitely made things easier. As tight as it was coming off, I didn't have the problems putting it back together that I did taking it off. So I'm going to go ahead and just start stuffing this guy back in and connecting all my pins together, and work on getting it powered up and checking it out to see how it works. So that's going to be the next part of the project. I've decided to cut this part at this point. There's plenty of work to follow, and I didn't want to make the video too long and too involved, so we'll cover things as I go along in the next part. It's going to be an attempt to calibrate the meter with the trim pots I have installed, and hopefully things will come out okay. So I hope if you're interested in that video, please feel free to return. And if you enjoyed this content, please feel free to like. And if you'd like to see more videos like this and be notified, please feel free to subscribe. And I thank you for viewing. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.